Hello my friends, in this video we will be taking a look at the autosomal DNA results, predicted phenotype traits, and G25 results of a Iron Age Celtic sample from the southeast of France, from somewhere in this region in southeastern France. The sample lived in 3 centuries before the Common Era, so quite a long time ago. Now, Celtic people at some point in the Iron Age lived everywhere in Europe, not only in Western Europe, but also in Central Europe, in Italy, and even in Anatolia. There were Celtic people living in Anatolia. I think they were called Galatians, who lived in Central Anatolia. So Celtic people at this time lived in a lot of places in Europe, and that includes southeastern France, where this sample is from. Now, his Y DNA is R1b L51, which is nowadays very typical, very common lineage for Western Europeans. It is widespread in Britain, in Iberia, which includes Portugal and Spain, in France, in the Netherlands, and Belgium. And his mitochondrial lineage is V3A. Now, I found this site which gives very interesting breakdowns of the samples, what they score with Y-sec. With Y-sec, he scores pale skin, black hair, and blue eyes. Very interesting breakdown. So this kind of a result tells me that most likely this sample has blue eye haplotype 2. Not even most likely, but definitely has blue eye haplotype 2, because that's what you need to have to score blue eyes with Y-sec. Y-sec, a prediction for eye color and hair color and skin color is very simple. It's very simplistic. It's much more simplistic than Shakot. You can tell everything about the sample's genotypes by this prediction, right? Because it's so simplistic. It's not polygenic, it's very monogenic. So I already know what the sample's genotypes are from this prediction. But anyway, we are still going to look at what they score with Nashakot, because it will be quite interesting to see. So we do know that this sample has blue eye haplotype 2, but I am still quite curious to see, does he have blue eye haplotype 3 and 1? That is also quite interesting, and it looks like he does, because with Nashakot he is also scoring blue eyes, and to score that you need to also have blue eye haplotype 1 at least, and most likely he also has blue eye haplotype 3, which we will find out in a couple seconds. He is scoring dark brown hair instead of black, so most likely he has dark brown hair. He's scoring 21.9% odds for black hair, 23.8% for light brown hair, but most likely he has dark brown hair at 30.6% odds. And he's actually scoring olive or Mediterranean or white skin tone as the most likely skin tones for him to have. And for hair texture, he is scoring wavy or curly hair texture. And for nose shape, he is scoring Greek shaped nose. That's what's interesting, is that seems to have all the light color variants for eye color, and all the relevant variations for eye that are relevant to eye color. So he's got BH1, he's got BH2, and he's got BH3. So he's got all the eye color haplotypes that are relevant to blue eyes in HERC2, which is very, very interesting. So he's got a very if you look at only HERC2 in terms of eye color predictor, OCA2 and HERC2 eye color calculator, that's going to look very, very blue. You can see, if you take into account only HERC2 and OCA2 genotypes to predict his eye color, that's going to come out very, very blue. But if you take into account all the other genes that play a role, then it's going to be a little bit different. The result is going to look a little bit different. Still blue, but a little bit less blue. Now, the reason he is scoring black hair with Y-sec is because of this. It's because of these genotypes, which also contribute to him scoring dark brown hair with Shakot, although to a lesser extent. He should have, without these genotypes, he would be scoring blonde with Nashakot, but because of these genotypes, he is scoring dark brown hair with Shakot. Although with Y-sec, they are really the impact of dark color variants in these variations is really overestimated, and because of that, he is scoring black hair with Y-sec. Well, it is what it is. And he's got 2 light color variants in this version of SLC2485. So he's got a lighter skin tone. And what about Keto G? 2 light color variants here, so lighter color of skin. Very, very interesting. And I'm actually quite interested what he would score for, for Snipper 3 eye color, we don't even need to check. That would be blue. Now, for Snipper 3 hair color, it would be blonde. And I'm going to show it to you right now, because Snipper 3 hair color actually does not consider SLC4582 or if it does, it doesn't give them that. It doesn't play that much of a role in classification. I can give you this proof right now. Yes, it's gonna be blonde. Yeah. So as you can see, the snipper prediction for hair color for him is actually blonde, which is very different from Wysek. So Wysek prediction was black. Snipper prediction is blonde. My prediction is dark brown for hair color for this sample. For skin color, I think snipper prediction is going to be white. Actually, it's. I would be very surprising if it would be anything other than white. But we can check that right now. Let's check what is the skin color prediction. Yes, it's going to be white. So the skin color prediction is white with snipper 3. So this sample is quite light in terms of pigmentation. He's got very blue eyes. 65% odds of blue eyes is very high. Very low odds for hazel eyes. Only 4% odds for hazel eyes is very low. Very low. If you've been following my channel and you've been looking at samples and the results with Nashakot that I've been posting on my channel, you've probably noticed the pattern that it's kind of uncommon to see samples scoring so low for hazel eyes and so low for brown and dark brown eyes. It's really uncommon. So this is a sample that's very light in terms of eye color. And yes, he does score dark brown hair and he does score olive or white skin tone, but still, this is quite a light pigmentation sample. And if we look at the phenotype oracle, the phenotypes that are closest to him, we see that the phenotypes that are closest to him are also quite light phenotypes. Like, for example, North Pointed right here, it's a rather light phenotype with blue eyes and, well, it doesn't have light hair. It has, I would say, brown hair color. But that fits the criteria. That fits the classification, actually. Blue eyes and dark hair. That's exactly what this phenotype scored with Nashakot. The second closest phenotype is corded. The third closest phenotype is also corded. And the closest phenotype mixtures, let's look at them. Right. So the closest mixture is actually a mixture of this stranded phenotype with green eyes or blue eyes plus Nordic. And the second closest mixture is a mixture of pointed plus itself. And the third closest mixture is a mixture of pointed plus corded. Very interesting. So somehow, for some reason, a mixture of stranded with blue eyes plus Nordic is actually closer than pointed plus itself, which is very interesting to observe. That's quite fascinating. So this is a Celtic individual. I would say that stranded phenotype with blue eyes to me looks quite Celtic. And the Nordic phenotype right here is also quite a Celtic phenotype. North Pointed, I would not say it's a very Celtic phenotype. It's more of a, it looks more Eastern European, but it's a general European phenotype. There's people in, there's Alain Delon, which is an actor from, I think he's a French actor. So he also looks quite similar to this pointed phenotype, North Pointed phenotype, Alain Delon. You can look him up. Maybe this sample looks a little bit like Alain Delon, actually, in terms of his phenotype and appearance. But let's close that and let's look at the... Actually, let's look at the ethnic calculator results. That may be interesting to see. Yeah. So I am going to zoom in and show you the S&P count with the ethnic calculator results. And I'm not gonna comment on that, but just take a pause or maybe take a screenshot, and I'm gonna 1, 2, 3, and I'm gonna wait a little bit. I'm gonna close the tab after a couple seconds, and we're gonna move on. Let's go and talk about biomarkers results. Right. So for biomarkers, this individual scores higher than average levels of vitamin D, which is really good. Higher levels of LDL cholesterol, which is bad. Lower levels of HDL cholesterol, which is also bad. So some cholesterol problems, perhaps. Low levels of glucose, which is good. Higher levels of hemoglobin, which is okay. Higher levels of blood pressure, not higher, like average levels of blood pressure, which is okay. Definitely higher levels of iron in the blood. Wow, that's crazy. What's up with the iron in the blood? That's really crazy. That's a really crazy score. Let's look that up. Let's look up hemochromatosis. Okay, so he's got two variants of the C282Y hemochromatosis mutation and likely has hemochromatosis. Okay, so this sample actually likely has hemochromatosis. That's actually quite crazy. So this sample likely has Celtic curse because of mutations in the HFE gene, which is really rare, really uncommon. That's very interesting. So we found a sample with the Celtic curse. This will probably go in the thumbnail. That's really, really interesting. Yeah, this will go in the thumbnail of this video. We found a sample with the Celtic curse. He's got a above average level of sex hormone binding globulin in blood. He's got below average level of red blood cell count in blood, above average telomere length for telomeres, and below average height, so slightly shorter than average. All right. Now let's move on to polygenic risk scores. We're gonna ignore everything that's close to 1 and only talk about the risks that are either very below average or above average. So much lower risks of kidney stones, lower odds of arrhythmia nodosum, lower odds of hemoglobin E disease, lower odds of migraine, higher odds of lupus, lower odds of gout, lower odds of thyroid cancer, higher odds of polycystic ovary syndrome, which is okay because this sample is not a female. Low odds of age-related macular degeneration, higher odds of Tourette's, higher odds of epilepsy, slightly higher odds of asthma, slightly higher odds of leukemia, slightly higher odds of vitiligo, slightly higher odds of myopia, higher odds of male pattern hair loss, which is not surprising because, as I've said previously, if you watch my videos prior to that, it is typical for Europeans and people of West Eurasian descent in general to have higher odds of male pattern hair loss. People of West Eurasian ancestry tended to lose hair more at an earlier age and at a higher frequency than people of other ancestries. Lower odds of cardiovascular issues, which is really good to see, and higher odds of ADHD and higher odds of unipolar depression, and slightly lower odds of bipolar type 1, and slightly lower odds of schizophrenia, and slightly lower odds of type 1 and type 2 diabetes, and slightly lower odds of Alzheimer's, and slightly lower odds of multiple sclerosis. So far, I'm not seeing anything concerning in this result besides the score for hemochromatosis. No risk variance for breast cancer. Average score for prostate cancer. He's got a 14 risk variants for testicular cancer, and he's got 2 risk variants in all the important variants for testicular cancer and the keto G gene. So when it comes to keto G gene, he's quite cooked, but that is typical for Europeans and people of West Asian ancestry in general to have these genotypes, these risk variants in keto G. So he's really not any more cooked than any other European is. So there is nothing too concerning in this result when it comes to risk variants for testicular cancer and keto G. One risk variant for celiac disease out of 8, and for celiac disease, that's quite typical. No risk variants for GSS, 6 for Crohn's out of 22. None of them are marked as important, so we can skip over that. Nothing for Riefenstein's. We do see 1 risk variant for Parkinson's out of 10, but this is probably a miscall. This is most likely a miscall because it's called heterozygous and it's quite rare. You see, the thing is, when I analyze these ancient genomes that are like 1240K files, most likely when I see these heterozygous calls for rare diseases, they are miscalls. If you see these in my heritage or ancestry or 23andMe files, most likely they are not miscalls because my heritage, 23andMe, and ancestry, the chips that they use to get these to get your microarray sequence files, they use much higher quality chips than these researchers do. So because the chips are much higher quality, you do not see these miscalls that often with my heritage or 23andMe or ancestry. That's why if you see these rare risk variants in your file, most likely they are genuine. But if you see them in like ancient DNA from some Cheddarman or something, most likely these are miscalls. That's why I'm skeptical when I see stuff like that, right? That's why I'm skeptical. That's why I say most likely that's a miscall because it's just so rare and it's a heterozygous genotype. I don't see anything else. I have a terrible headache. I'm sorry. Maybe I'm going on tangents and not being very productive with my words. Um, Okay, I'm not seeing any other. There is also this genotype, which is actually homozygous risk variant genotype for leak from many. And this is very difficult for me to say. Is that a miscall or is that a genuine genotype? Because miscalls tend to be heterozygous variants, heterozygous calls. But in this case, it's a homozygous call, and it's very uncommon as well. So this might be a genuine genotype that this individual has. But also, I don't know. It might also be a miscall. I'm not gonna comment on that. I'm gonna pretend that I don't see it. But what I do see, what I know is genuine because I have never seen miscalls there before, is that this sample has a predisposition to hemochromatosis. Let's go over the monogenic traits and see if we see anything else there. So for warrior versus warrior, the sample is definitely more predisposed to being a warrior. Warrior phenotypes, lower dopamine reuptake and higher dopamine levels, over stress resiliency. So in terms of COMT, MAOA, and MAOB enzymes, this sample probably has a predisposition to lower activity of these enzymes and therefore higher dopamine levels. For D2 dopamine receptors, this individual has a predisposition to intermediate or lower dopamine D2 receptor sites in the brain. So some protection from such conditions as schizophrenia and bipolar. For levels of 5-HT and serotonin, this sample has a predisposition to lower or intermediate levels of 5-HT and serotonin, so some predisposition to such conditions as depression and anxiety. This sample does not have dwarfism. And for autism, this sample has a predisposition to higher odds of autism, which is very, very interesting. Now, for lactose persistence, let's see. The sample has a predisposition to intermediate or higher odds of lactose persistence, lactose intolerance. Excuse me. So this sample actually is not lactose persistence. He does not carry the European variant for lactose persistence. He actually does not carry any variants, not even European ones, not even the worldwide variants. He doesn't carry any variants for lactose persistence, not the Arab variant, not the worldwide variant, not the European variant. He doesn't carry any variants for you for lactose persistence, which is very, very interesting. But even despite that, even if you don't carry any variants for lactose persistence, you still have a very large percentage chance of ending up lactose persistent, nonetheless, just because of the way this works. So many people don't have any of these variants and are still lactose persistent that it's chances are this sample has a very, very large chance of still, despite not having any variants for being lactose persistent, still ending up having no trouble tolerating and generating this enzyme, lactase enzyme, by himself. For empathy and OXTR, this sample has a predisposition to lower or average level of empathy based on needs, forests, and peace. Very, very interesting. And for hemochromatosis and diabetes, we already saw that. He does have this genotype here in HLA, which leads to 5 times increased odds of type 1 diabetes. But so this might contribute to a increased risk of autoimmune disorders in the HLA gene panel. But there's also this genotype, which is a 7-fold decrease in risk of type 1 diabetes, which also contributes to the HLA gene panel. So that's interesting. These are both going in the HLA gene panel. And of course, this one is a bad genotype. This one is a good genotype. So they're both going in the HLA gene panel, which both contribute to the HLA gene panel in a different way, of course, but they both contribute. For Alzheimer's, no risk clearance for Alzheimer's and APOE. For multiple sclerosis, no risk clearance for MS and HLA. Cardiovascular disease panel, predisposition to intermediate or lower odds of cardiovascular issues for cardiovascular disease panel. Pretty good to see. Okay, for vitiligo panel, he does have heterozygous genotype for HLA variants for vitiligo. So there are some risk variants for vitiligo in the HLA gene. Once again, this will contribute to the HLA gene panel in a negative way. Any risk variants for conditions in the HLA gene contribute to the HLA gene panel more in a negative way than in a positive way, because mostly they are quite rare. Any of these rare variants, any risk variants in the HLA gene are rare variants, so they always contribute more in a negative way. So if you see one risk allele in HLA, it's always going to contribute in a negative way. Almost always. There's some exceptions, but almost always it contributes in a negative way. So in this case, for vitiligo, for example, or multiple sclerosis, it's going to contribute in a negative way. He's got European genotype in EDAR. He's got high odds of protruding nasal bridge. He's got larger nose size. He's got higher odds of missing teeth. Pretty interesting. No micropenis. Mix of muscle types, likely more sprinter rather than endurance athlete. Not an Asian flusher. Risk of heart failure due to beta blocker medications is below average. Pretty good to see. He's not a carrier of albinism mutations. Pretty good to see. He's not a carrier of familiar Mediterranean fever mutations. For MTHFR panel, he has genotype for normal genotype, which just leads to good levels of homocysteine levels, and another genotype which leads to increased levels of homocysteine and possibly impaired folate metabolism. So this will impact the homocysteine panel, but not in a very negative way, because this other genotype right here impacts the homocysteine panel in a very positive way. I think the impact of this variation and this variation is more or less equal. I don't exactly remember the way I coded it, which variation has the larger impact. Maybe they both have the same impact. I don't remember, but I don't remember exactly. I think one of them has a slightly larger impact, but anyway, maybe it's the same. Maybe it's the same impact for both of them. But I can tell you that having a genotype that is homozygous good, and then a heterozygous genotype, most likely the homocysteine panel is going to look quite good. It's going to look quite good, because also there is also the CBS gene, which affects the homocysteine panel as well, and we're going to get to it a little bit later. For rare diseases, he's got I don't see any rare conditions here. I see common but 10 times higher glaucoma risk, and that's it. For celiac disease, no risk variance in HLA, one risk variant in CCR3, but that's not an HLA, and that's it. Okay. Crohn's disease, no risk variance in Crohn's disease, no risk variance for Canavan syndrome, HIV and AIDS panel, no protective variance in HLA-C. For HLA gene panel, he's got predisposition to intermediate or slightly higher odds of autoimmune disease. That's very interesting. We can check the HLA genotypes right now and see what genotypes contributed to this. So, looks like for HLA-A, there's one genotype which leads to slightly higher odds of multiple sclerosis right here, which contributed to the score in a bad way. There's, I mean, I don't see any. There's this genotype which contributes to the score in a bad way as well in HLA. I think that's DQ. There's these genotypes which contributed to the score in a bad way for vitiligo. There's this genotype which contributes to the score probably in a bad way as well for allergies, but I don't see that many. I don't see that many genotypes which contribute to the score in a bad way for HLA actually. This one right here for HLA-C also, which slightly, it's typical. It's the most typical genotype for HLA-C though. It's not a rare genotype that's bad, that really tanks your result. It's the most common genotype. It's just lacking the protective variants for HIV protection. So it's not like a really uncommon genotype that tanks your result. It's very common. So really, this sample doesn't have all that many uncommon genotypes in HLA. That would be really bad. And you can see from the result isn't that awful. There is 41.8% odds of lower odds of autoimmune disease, and that's the same percentage for intermediate or slightly higher odds of autoimmune disease. The result really is not that awful. It's it's okay. It's an okay result. For CBS panel, we are finally getting to it. The CBS panel result is looking quite good, actually. As I was saying, it's looking quite good. It's scoring lower or intermediate levels of homocysteine. I think what's contributing to this is that he's also scoring these for CBS panel, so slightly decreased homocysteine levels here, lower levels of homocysteine here, but there is also a genotype for higher levels of plasma homocysteine. So I guess it's like a mix up. a mix of genotypes. Some genotypes predisposing to higher, some genotypes predisposing to lower, some genotypes predisposing to slightly decreased. So I guess it's like a mix up of genotypes for the CBS gene panel. And there's also some risk variance for homocystinuria in the homocystinuria panel as well, which slightly increases the levels of homocysteine as well. But it looks like overall, the predisposition overall is to lower homocysteine levels, which is really good to see. The sample is quite healthy. The only unhealthy part, the only unhealthy thing about this sample that I noticed this far is the predisposition to hemochromatosis or the Celtic curse. The Celtic curse, in case you don't know what that is, and we can scroll up back to it. We can get back to it right now. Where was it? Hemochromatosis is essentially when your organs accumulate excess iron, as it says right here on Johns Hopkins medicine official website for hemochromatosis, and it affects 1 in 300 people in the United States. Pretty common. It mostly affects people of European ancestry, of Northwest European descent. It is most common in Caucasians of Northern European descent, as it says right here, and it's a very insidious condition because the iron doesn't exit out the blood, and it accumulates and it messes up the liver, and it also messes up the heart. It messes up so many organs. It leads to multiple organ failure, and it's a very insidious condition. Now, some theories have been made in the past about the origin of this condition and why this metabolic issue presented itself in um, people of Northern European descent. And one of these theories is that in Northern European people, historically, their diet did not consist of that much iron. So they evolved, or somehow, I don't really know how to phrase this in a correct way. They evolved in a way to store this iron better, and their bodies have evolved. I'm sorry, I have a hard time phrasing my words in a good way, but their bodies have sort of evolved in a way to store the little bit of iron they get from their food, um, in a way that's most efficient, and that's why they are so good at conserving this iron. And now that the diet has changed, and now that there's so much more iron in the food, this is a detriment to them, because now their bodies are very good at storing this iron, and there's too much iron that they're getting from the diet, and it is causing them to have hemochromatosis, which is a issue where there's too much iron in your system. Maybe I explained it good, maybe I explained it bad, I don't know. I'm sorry if I did a good job, or if I did a bad job, I don't know. Okay, so this sample does not have any muscular dystrophy myopathies, does not have ADL either, which is good to see. Actually, I can't say that because there is no risk variance, zero total for ADL, so I can't really say if there is any risk variance at all, because nothing was found in the file. For color blindness variance, nothing was found for OPN1MW or OPN1LW, and there is no risk variance for OPN1SW, really good to see. For FCO gene panel, lower odds of obesity overall, really good to see. So no predisposition to obesity based on 1, 2, 3, 4, 5, 6 SNPs, really good to see. For syncope based on 1 SNP, this sample has got a average predisposition to syncope. So syncope, in case you don't know what that is the predisposition to faint or lose consciousness based on blood not flowing to your brain. And for biotraits panel, the sample has 1 copy of the hunter-gatherer and 1 copy of the farmer CLT-CL1 gene variant, which leads to intermediate ability to process carbs and sugars. Very, very interesting. Now for the blood group panel, this sample has a type A blood type, which I've seen a lot frequently. It looks like, from the samples I've been analyzing recently, a lot of them don't have type O blood type, which is the most common blood type worldwide, and a lot of them have like the type A or type B or something else. But that's kind of surprising to me, because I was expecting most samples to have type O blood type, but it looks like this sample actually has type A blood type, which is very, very interesting. Not the most common blood type worldwide, but it is also found at low frequency in Europe, in Europeans. Some Europeans do have blood type A. I think I have blood type A in my family as well. My grandmother has type A blood type. So this sample has blood type A, and that concludes my video on the sample on this Celtic individual from southeastern France from 3rd century before the Common Era. So I hope you enjoyed this video. I hope you found this video to be interesting and fascinating. Make sure you leave a like and subscribe. If this is the first video you watch, you subscribe. If in case it's not, then you just leave a like. Leave a comment if you want to comment on something. And also check out the description. In the description of this video will be a lot of very interesting things. Make sure you read the description. Thanks for watching. Goodbye.